the first thing that I want to do with you guys is let's look at problem number 8 from the practice test. And I want to talk to you about what you need to be able to do, because you're going to need to know what angles do graphs actually intersect at. And you also need to know what are the angles where a graph comes out of the pole and gets sucked back into the pole. So if you want to know the angles where graphs intersect, you're going to take the two equations and it turns into a system of equations. But if you've just got r equals and r equals, set them equal, because it's just the angles that you need to solve for. So for this problem, that starts us off with root 3 equals 2 cosine 2 theta. Now, I'm realizing that some of you don't have a lot of experience, at least the normal amount, with solving trig equations. So understand that goal number 1 is to just that trig function, don't worry about what's inside of it, just isolate the trig function. So we get that cosine of an angle is equal to root 3 over 2. Now you need to be ready to do unit circle, or whatever is equivalent to unit circle. Right now I'm not going to worry about the fact that the angle is 2 times theta, just that angle creates a cosine of root 3 over 2. Cosine represents the x-axis on a unit circle. The three special numbers are 1 over 2, root 2 over 2, root 3 over 2. So it is the third one of the 3 away. And that takes us to only a pi over 6 of a turn from 0. You can also look at this as negative pi over 6, but I'm going to put 11 pi over 6 down. Now, if you were answering what is the solution to all equations, I'm trying to make a big picture of trying to help cover some of the holes you might have with your trig. If I needed to say all solutions, then I would take my two answers and put plus 2 pi times any integer. Integer includes 0, 1, -1, 2, -2, and that just is about how many times can I go around the unit circle and then stop at that same exact spot. Now, this is what the angle in cosine is equal to. So 2 theta is equal to these two expressions if I want to get every single possible solution to that equation. Do you need to go that far on the test? No. But I want to make sure that you're understanding how to solve your equations or have a little bit more practice behind it. So I can set 2 theta equal to the pi over 6 plus 2 pi n, and I can set 2 theta equal to the 11 pi over 6 plus 2 pi n. And then when I divide by 2, I'm going to get a solution of pi over 12 plus pi n and 11 pi over 12 plus pi n, because I'm dividing by 2. And then that gives me a whole slew of solutions for when n is equal to 0, when n is equal to 1, and however far I want to go. So I just wanted to double check with you that you know how to do your equation solving or are reminded of it. Because there will be times on the AP test where you do not have a calculator, and you need to be able to go through this possibly. But even more so than that, my bigger concern is a lot of you are going into the next semester of calculus after this, multivariable calculus. If your trig is weak, you're going to have a harder time. So after the AP test, I'm going to strengthen your trig more. Right now, I'm just trying to strengthen it enough for the AP test and what could possibly show up. It doesn't have to be as strong for the AP test as it needs to be for your next class. So all in all, pi over 12. For a lot of you, you just needed to get pi over 12 and then use symmetry from there. But I wanted to go through the whole process. But when you're in the middle of a test or even a homework problem, you don't want to sit there and spend more time than you need to. So you should see that we've got pi over 12. That makes this angle a subtraction of pi over 12 from our pi over 2, and we could keep going. And I think you've got that idea with symmetry at this point. So that's one issue. Another issue is, where does this rose curve have a 0 radius? Now, you can probably look at the picture and recognize, hey, you know, it kind of looks like a 45-degree angle there. It is, and you can get away with that. I want to double check, though, that you understand how to cope with this given any equation that could be thrown your way. So if this is the equation that you have, and you want to know where does that get sucked into the pole, you're going to let the r be equal to 0 and solve that equation. So if 0 equals 2 times cosine 2 theta, then I'm just going to not write the times 2 because 0 divided by 2. Yeah. So now what you want to think about is not the 2 theta, but the fact that cosine is equal to 0. And then what are the angles where cosine is 0? And hopefully you remember a little bit. Pi over 2, 3 pi over 2, all the over 2's. And when I make that be 2 theta, I'm just going to put, and then there's a dot, dot, dot the other way, but I don't feel like writing it at this exact moment because I don't have space. Then theta is divide all of them by 2, and now you've got that pi over 4. So just be aware of that. Now, on tomorrow's test, you're going to be allowed a calculator. If you have a calculator and you need to solve equations, you can let the calculator do the hard work for you. But it comes down to still, you need to realize that to solve for the angle where they intersect each other, you need to look at the intersection of these two. You're not going to find it easily in polar mode. You want to actually be in regular function mode. You want to maybe put into your first y the square root of 3, put in your second y 2 cosine 2x, and then look at where those graphs intersect. The x-coordinates of their intersection are giving you the same values as the angles where these graphs are intersecting. Then also you can graph this one, and if you need to find when does its radius equal 0, you can just find the zeros. Your calculator will do that. After you graph, you can do second F4, and down there is, I think most calculators say zeros. They've gone through different names that they use for it, depending on what version you have. But anyway, you can use that technology instead of going through this algebra if needed. honestly, I'm more concerned about the AP test with this issue than I am about tomorrow's test, because with tomorrow's test, I understand where you guys are at. So your good news is I'm not going to test you nearly as hard as I usually test people on this, because usually we have a lot more time to do this and ask questions and all sorts of things. Plus, usually people didn't miss the end of their trig units in the previous class. That just makes it worse all on top of it. So let me tell you that with tomorrow's test, you will be getting a total of 5 problems. 3 of those problems are going to be area. The problem that I have on screen right now, I will not give you a problem like that. I will go over this problem with you, but I feel like with how much you have been exposed to, I don't feel like I should be testing you on that right now. But you do want to feel good about it before entering the AP exam. As far as what are the 3 problems going to be, one of them could be somewhat similar to number 10, a simpler problem where you're just showing me you know the basic area formula that's going to be used. And with this problem, you're being asked to find the area inside one loop. I'll give you the picture, you'll be able to see it, and you're looking at what are the angles that create a loop. So basically, when is r equal to 0? 0 divided by 3 is 0. And if you had to, could you solve that on a calculator? So just be aware that you will have that access tomorrow. Now, what are the angles that make sine equal to 0? And then when I divide by 3, I get angle 0, angle pi over 3, and we can keep going, but that's good enough. If you then integrate from 0 to pi over 3, and you use your 1/2 r squared d theta formula, where this is your r, you will get the area inside one loop. You could also use symmetry and integrate from 0 to pi over 6 and double the area. Now, I want to double check before I post the answers of, I spent time with my calculator getting the answers, although period 1 did verify this one for me. So on tomorrow's test, you're going to have 3 area problems. One of them will be simple like this. And what's going to happen is you're going to have paper that you'll take a picture of, or if you're writing on a screen, you'll save that. And you're going to just upload all your work into one Google Classroom document. On GoFormative, I'm going to have a place for you to put the numerical answer of your integral. If you don't have the correct answer, then I'm going to sit down with you and I'll set up little sessions, little after school sessions for you to come in and show me the work that you turned in. So I'll have that work and know that that's what you did. But as I talk with you, I will figure out whether you really know your stuff and just made some really ridiculous error, or that you needed some help getting there, and, I'll give you some I tried points. So I'll be able to get this back to you immediately by doing it this way. But know that you're going to get more points back for incorrect answers if you know how to do it correctly and have a decent amount of correct stuff on the paper you turn in. So you're going to, on paper, set up your integral. And then on GoFormative, you're just going to type in the area number. Make sure you have 3 digits after the decimal point. And so period 1 confirmed that that was the correct answer to that problem with number 10. Now, the other 2 area problems are going to be an inside-outside. And can someone verify for me that that is the correct answer for number 9 that you got with your calculator? If I have enough verifies, then I know that I didn't screw up. I got 1. I usually look for at least 3. Got 2, 3. Okay, we're good. Because I like to be very sure. And if I have 3 people say, yes, I got that same thing, I've never had that not be workable. Anyway. So you're going to have an inside-outside like number 9 and like, hold on, number 6. 6 and 9 are inside-outside problems. Now, can you verify 2.739 for number 6? That's what you got with your calculator? You guys probably have it written down. No? I'm getting no's. Uh-oh. Oh. Oh. Okay. Did anyone online get that number after putting it in your calculator? Excellent. Okay. This one was cruel and tricky. I'm highlighting something that was cruel and tricky. And be careful of that on the EP test. Do know that the test I'm giving you tomorrow is something that I feel you have had sufficient time and study to be able to do well on it. I'll just say that. But this one is tricky because it's giving you r squared, and you get into the habit of always squaring the function, and it's already r squared. So be careful with that. Okay. When you're dealing with an inside-outside area, those are actually easier because they can usually be dealt with as one single integral. Why are you doing this to me? Oh, because it's word, not the other one. Anyway. Usually you end up only dealing with one angle range. And I want to emphasize to you that when you have an inside-outside, what you're doing is between those 2 angles, from the pole, draw all the way out to the one that you are expected to be inside of. You cannot get the area without having those spokes go all the way down to the pole. So while you're going to do your 1/2 r squared d theta on this particular curve from between these 2 angles, also between those 2 angles, you are going to need to subtract away from the pole out to the function where it needed to be outside that function. And if you draw these spokes, it can really help you to recognize who you're finding the area of for that angular sweep. And you end up subtracting. So with these problems where it's inside, outside, you end up needing to subtract. Now, it's not a complete 100% every time you see an inside, outside, that's what you do. But I'm only giving you tomorrow what you can expect normally. The AP test won't be necessarily as kind, so I want to do, so I've presented to you harder than what I'll put on the test. And we'll keep practicing as we go along. Now, the third area will be inside both. With inside both, that would be like numbers 5. Number 5 was inside both. And can someone verify that integral answer? 15.708. Good. And then another one that was inside both was number 8. When you're dealing with the inside both, you have to set up separate integrals for separate angle ranges. Because when you're inside both, you have to, while your angle is sweeping along, you have to stay with the curve who is closest to the pole at all times. And at that intersection, you have to swap who's closer to the pole. So I have someone agreeing with the 5.598? All right, excellent. Woohoo. So with that problem, actually, was that number 8 that I was just showing you? Okay. So with being inside both, for one, you can use symmetry to help you out. And the simplest way that I'm going to talk about symmetry is to look at from 0 to pi over 4. If that is the only region that I take area from, how many regions with that area do I have? I have 8 of them. And there are a variety of ways you can set up your integrals, which is why I decided it would be best if you put a numerical answer into the Go formative. And by the way, you do have to have work. If you don't have work, you will not get credit. Now, when I start off from angle 0, I am going from the pole to the closest of the 2 polar curves. And I am following the circle whose equation is the square root of 3. Now, you can bring in area of circle instead. It's up to you. But I'm going to say 1/2 r squared d theta, where r is root 3. And I am going to go from angle 0 until the intersection angle of pi over 12. When you are dealing with area inside both, you're not subtracting, you're adding. When it's inside outside, you end up having to do a subtraction. Now, again, I've got 8 times the area. But once I cross over pi over 12 and I draw spokes coming out, it switches the function that is closest to the pole. And you need to know that that gets sucked into the pole at pi over 4. So you're going to integrate from pi over 12 to pi over 4. And then 1/2 r squared d theta. But this time, your r is 2 cosine 2 theta. And then that'll get you that area. So as you look at the problems I've just talked about, let me also say again, I am not going to put a problem like this one on the test. Do you feel like that's doable? And it'll be straightforward problems, no sneakiness. Then the other 2 problems of the test are going to be, one problem will be like number 1 or 2. However, I'm not going to ask you for the name of the shape of the graph. All I'm going to ask you to do is convert from polar to Cartesian. And to do that, you need to know your right triangle or your right triangle formulas. And I would recommend first replace the trig functions with the ratios that that triangle gives you. Then play with your algebra. Again, just take the trig function, what ratio does that give you on the right triangle, and then play. I guarantee you that the problem I choose to give you will do one of 2 things. So with number 1, after you plugged in the trig ratios and you played with the algebra a little bit, you wound up getting an r squared who comfortably says, hey, remember Pythagorean theorem? Hello! And then you can call it a day. And you're going to type in the equation you have. It does not have to be solved for y. It doesn't have to be in any particular format. It just has to have x's and y's. Then you're either going to run into an r squared or you're going to run into a bye-bye of r. You're not going to run into just a singular r sitting around where you have to go, well, I guess I've got to replace it with a big giant square root of x squared plus y squared, but that makes a really awkward equation. And the value of converting from polar to Cartesian is more in taking you to an equation that you are already familiar with in the Cartesian world. Otherwise, it's just like, yay, and that's about as exciting as it gets. You can expect to see one of those. I won't ask you the shape, just convert. And then I hope you enjoyed problems 3 and 4. I realized that they were quite tedious. Good news. I'm not going to ask you problems like 3 and 4. That is your benefit of being in the COVID crisis. Normally, I do expect people to do problems like 3 and 4. But you have not had enough trig and enough time with the polar to where I feel like you have been prepared for that test. I will tell you the AP exam, you can get away with not being incredibly strong with your trig and your algebra and pass the test. That doesn't make me happy. But I've seen people who have weak skills with their algebra still be able to pass the exam. People who get 5s on the exams usually have some good, strong math behind them to not screw up as much. If that makes sense, what I'm saying. However, I will tell you, I've seen people who just work really hard get 4s. So if your trig is weak, I'm not overly concerned about the AP test. I am more concerned about about you using trig after this is all over. You might go into a career where you do need trig. Then, unfortunately, I just have to go back to school and say, if you're going into 3rd semester calculus, if your trig isn't strong, you're going to have some problems. So after the AP test, I want to spend time strengthening your trig. But this stupid AP test is way too soon, and I've got to focus on making sure you're ready for that test, and then I can strengthen what I know the AP test isn't quite as testing, if that makes sense. So for tomorrow's test, all I want you to be able to do is find me the slope. That's it. I won't ask find the equation of the tangent line. I will ask you to find the slope of the polar curve at a particular angle. That's it. Between numbers 3 and 4, that's all I'm going to ask of you. And so that's your 5 problems. 1, be able to convert an equation from polar to Cartesian. 2, be able to find slope given a polar function at a particular angle. And then 3 area problems. 1 that's more basic, 1 that's an inside-outside, 1 that's an inside both. And that'll be it. And I'll be able to get your results back to you quickly and then set up appointments with you to go over that. And that will also help you in preparation for the AP test. Trying to do a bunch of things at once. So in period 1, they did want me to go over finding slopes. So shall we? And just do it. And I'm going to tell you right now, I'm not going to give you a problem like this one, because I've got to say that normally there's a lot more, so much as I feel like I'm repeating myself at this point. So I won't. Okay. So what if this was what we were given and you were just asked to find the slope of that curve at that angle? So what you need to do is start with what is y equal to and x equal to as a formula. Now, I will tell you that I write my y's on top so that I don't mess up when I do slope. Do some of you feel me on that one? If I write the x on top and the y on the bottom, I'm bound to accidentally have a dx dy. So you know the formulas are, for y, it is r times sine theta. Are you with me online? And x is equal to, good, r times cosine theta. And then you're just going to take whatever that r equation is and put it in here. Now, if you see any legitimate shortcuts, feel free to use them. With y, you can choose to use the product rule, or you can choose to use the chain rule. It's up to you. For x, oh wait, I lost a 2, didn't I? There we go. For x, Does anyone happen to see a familiar look to that, to sine theta, cosine theta? Don't worry about it if you don't. Anyone over online kind of go, hey, I think I remember that in a trig identity. Unless you know for sure what that trig identity is, don't do it. Anyone happen to know, just off the top of their head? Then in that case, between one person and whatever quiet people don't want to answer, and that's how many people knew this trig identity between two classes. Part of it is because you didn't spend as much time with trig. But even still, normally, it's usually only a very few people who see it and have just that good of a memory. This happens to be sine 2 theta. There's a trig identity for that. If you recognize it and you use that, you can. But I'm going to do it as if you didn't see it because most people won't. I'm just going to write 2 times sine theta cosine theta. And then when I go about the derivative of x, I'm just going to make these my two functions that are multiplying. As I take the derivative of y, I want to point out that sine squared is a sine of theta being squared. So it's a baby function. You really have 2 times blah squared. So now I'm going to start that. Once you have these, your next step is, what is dy d theta? What is dx d theta? So for dy d theta, if you have constant multiple 2, and then you're taking the derivative, it's blah squared. Derivative of blah squared is 2 times blah. Give mommy her baby and multiply by the derivative of that baby, and chain rule is done. Then I'm going to do a keep the first function, multiply by the derivative of the cosine, plus this time derivative of that function will be 2 cosine theta times keep the second function as is. And you're going to have that slope written on paper. Then you're going to plug pi over 6 in, and you need to know the sine and cosine of pi over 6. So unit circle time, here we go. Angle pi over 6. You know that there's pi over 6 and pi over 3 cut it into thirds, and then there's a pi over 4 cutting it in half. The x-coordinate of this point is your cosine, and that is 3 special numbers out. So the cosine is root 3 over 2. And then for sine is the y-coordinate, and of the 3 special numbers, it's the first one up, so it's a positive 1/2. From there, you're just going to throw those numbers in, and you're going to write down the answer, but you may want to simplify that before trying to type that in. Yeah.
So, especially on the AP test where most of the examples you've given us have been calculator, is it okay if we just do like the plug-in derivative of this and then divide to that? So, like, say plug in the derivative of the x and have whatever value we need, and then divide the y and x.
You mean take the derivative with your calculator?
Yeah.
I want to see your work that you're doing the derivative.
Okay.
You can check with your calculator.
Okay.
But you've got to show me that you know how to do this. And here's one thing you need to know. In the multiple choice section, 30 of your 45 questions are no calculator. That's where your polar is going to be. And you can see that they often put the polar in the calculator section of free response. They don't always, but they do sometimes. So you may have a calculator with that, but very unlikely that you're going to have a calculator with the multiple choice. However, they could very easily put in a calculator section a problem that you don't need a calculator for, because all they give you are integral setups. And then it's like, what's the use of the calculator? I have to understand the integral setup and understand the symmetry that could possibly be within these integral setups. So, but if they were to deal with slope, that's going to be showing up in a no calculator section. And my biggest issue is just I want to make sure you're ready for that AP exam, and then also whatever your next math class is, that you go into it prepared with what you're supposed to have. Okay, so that covers what you will definitely see on the test tomorrow, and then I can go over some more things that I know people had trouble with. And I'm going to say for 3 and 4, understand them the best you can. The AP test isn't even going to go that hard on you. However, make sure that you understand the basics of horizontal tangent line means your slope is 0. That's dy d theta being 0. If it asks for vertical tangent line, that would be dx d theta equaling 0. Also understand that if you're doing an equation of a tangent line with a polar graph with the xy ordered pair, you need the xy ordered pair through the formulas. They probably would not go quite that far because it's time consuming. Everything about the test is an issue of how long does it take to do. And most of the good math problems take too long to do to be on the AP test. So there's your kind of good news. Now, let me talk about one problem. This one, because I know it was confusing for some people. To get the area of this shaded region. Now, when you solve for what makes this equation 0, it's sine theta being 1/2. Sine theta is 1/2 at pi over 6. And then again at 5 pi over 6. You're going to first integrate from this angle over to this angle, but it has to be that direction. So it's not 5 pi over 6 to pi over 6. You have to integrate from 5 pi over 6 to 2 pi more than pi over 6. And then you've got your formula, 1/2 r squared d theta. Whenever you set up an integral to find area, I recommend that you draw spokes coming out of the origin, because you've got to realize what you are finding the area of. As I kick off of this angle, these spokes coming out are getting some of what I don't want. You cannot avoid that as you integrate from 5 pi over 6 to 13 pi over 6. And then question? Because you have to make an actual sweep from 5 pi over 6. And then if you follow me, we're at pi, we're at 3 pi over 2, we're at 2 pi. So I have to look at the angular sweep that creates that graph. If you put here pi over 6, you would first of all get negative, and secondly, it would only give you what was drawn in that region. And what was drawn in that region is actually this. So that's why drawing the spokes is what I really recommend you do when you're doing area, because you want to think about, while I'm going through this angle range, what is it actually finding the area of? So then the issue of, you need to have this not be part of your area, because right now it is. So what you have to realize is, what are the angles that create that inner loop? Even though you don't see the graph between pi over 6 and 5 pi over 6, those are the angles that create it. And when your formula is 1/2 r squared, it doesn't matter if r is negative, it's going to square it. Yeah.
Would you also double the area going from 5 pi over 6 to 3 pi over 2?
Absolutely, yeah. You can also use symmetry and do 5 pi over 6 to 3 pi over 2.
Yeah.
And then in that case, you want to make sure to only do half of the other one as well.
Okay.
So you want to be aware that you're going to integrate this same exact function from pi over 6 to 5 pi over 6, and that is actually going to find you these spokes coming out, that area. It feels weird, and I don't feel like we've had enough practice with polar for you to be ready for this problem. But believe me, they would put this on an AP test. So really look at it, let it soak in, so that by the time the AP test comes in, it's kind of dug itself in a little deeper in your head. Okay, we are at the 10-minute warning moment. So now, oh wait, can you repeat what numbers? Okay, so on the test tomorrow, you will have a problem like 1 or 2 with converting polar to Cartesian, but I will not ask you to state the shape of the name of the shape of the graph. You will not have a problem like number 3, but number 4, I would make it a lot easier and just ask you for slope. Just slope at a point at the particular angle, not for the entire equation of a tangent line. So those 2, then there are going to be 3 graphs. One of them is going to be an inside both. Number 5 is an inside both. One of them is going to be an inside outside. Number 6 is an inside outside. And one of them is going to be a more straightforward one like number 10. And then I will tell you that I will not put a problem like number 7 on there, but the AP test probably will. Number 8 is another inside both. Number 9 is another inside outside. And then number 10 is the only one I have here for just, there's one curve. I might ask you for one loop. If I ask you for the whole thing, and okay, so if I ask you for the area of, say, for this. This problem is, let me think for a second, cosine peaks there, so it's out at 5 here, and then it's, oh no, wait, I just realized something. Hold on one second. I apologize if you wrote that down. I meant to do this. At least that, okay. So there's a reason anyway. Let me think. So it's going to be 3 here and then 4 in these spots. So what you're getting is a limosome that just kind of looks like a blob. Not terribly exciting. But if you were asked to find the area inside that graph, you're just going to integrate from 0 to 2 pi flat out. 1/2 r squared d theta. However, you can integrate from 0 to pi and not have the 1/2. But make sure you've got the symmetry right. Because if you decided, I'm going to integrate from negative pi over 2 to pi over 2, not symmetric. You see what I'm saying? Be careful of the symmetry if you choose to use it. So I might give you a problem like that, or it might be one loop of something. And then again, an inside outside and an inside both. Okay, then are there other things that you want to take a look at before class is up? Ooh, we've got a whole 6 minutes. Yeah. Do you want to see me go through one of these problems? Number 8. Oh, yep, there's 8. And it's being recorded so you can go back and watch that. Yeah. Number 5. That would be a great one. Okay. This one is inside both. And what I'm going to do is I'm going to draw the intersection angles. And if you're looking at area inside both, I'm going to start at angle 0 because, you know, it's 0 and we typically start at 0. So there is a little radius line that stays inside both. As I turn to a positive angle, I can see the curve that needs to be followed at that time to be inside both. But when I hit that angle of intersection, it's going to change the function it follows, because now the one that is closer to the pole is that circle. So I want to look at these as 2 separate areas. And what I'm going to do is just do a double the area, so a 2 times 1/2. In other words, don't need it. When I integrate from 0 to this intersection angle, I am following the cardioid, 2 plus 2 cosine theta squared. Then I'm going to add to that, and again, I'm doubling my 1/2. And I am going to integrate from this intersection angle to where this circle gets sucked into the pole. If you don't know the angle of intersection or the angle of getting sucked into the pole, those are found by this circle needs to be sucked into the pole. That's going to happen when r is 0. That's going to happen when cosine is 0, pi over 2. The angle of intersection is found by setting the 2 r's equal to each other. When I subtract 2 cosine over to the other side and then divide by 4, I end up getting, I need to solve when cosine is 1/2. So I think about the unit circle, cosine x coordinate, 1/2 will take me to the angles, to angle pi over 3, or negative pi over 3, but we're just looking at the 5 pi over 3, or where did 5 come from? I don't know. Pi over 3. So inside both, you have to set up 2 integrals and add them together, and be always aware of who is closest to the pole. The AP test might throw you some curveballs with this. I'm not going to throw you any curveballs with this. When the AP test comes around, just make sure you remember it's about who is closest to the pole as you sweep through the angles. When it's inside one and outside the other, I'm not going to throw you a curveball. It will be between 2 angles for both sections that you're concerned with. However, the AP test isn't necessarily going to stick to the standard problems. So you've got to think about how area is created, how it's really spokes coming out of the pole, and you're looking at, while theta is sweeping, where is that radius going to? Who am I wanting to follow? And so ultimately, who do I want to integrate? And when it's an inside-outside, you've got to be careful. You are likely going to subtract some stuff. Okay. Bell's going to ring any second at this point. So I hope that helped. You can come to my office hours 2 to 3 today if you need more help. And are you feeling a lot better at this point than when class started? Okay. Especially, you guys are lucking out. You get a far easier test than I ever normally give. And normally it's also, you're in your desk, I'm watching you, you have no calculator. You know that unit circle, baby. Now, I do want to make sure, though, that you are prepared for Calc 3.